Today we're going to talk about understanding how to solve complex fractions. If you have a problem that contains a fraction in either the numerator or a fraction in the denominator, that type of problem is called a complex fraction. These are the type of problems we'll address today. First, if you'll notice, there are fractions in the numerator and denominator. However, this one is an expression that must be solved first. Also, we need to remember that the fraction bar means to divide. Okay, if you understand that the fraction bar means to divide, it will make the problem a lot easier. So, let's go ahead and get started. If I'm looking at 5/9 and I'm looking at 4/3, I need to first be able to figure out the least common multiple by skip counting by 9 and skip counting by the denominator of 3 until I find the multiple that they have in common. The least was just the first one. In this case, it's 9. So let's set up our fractions with the addition symbol in between to represent 9s. So now this first fraction, 5/9, is already in 9s, so I'm just going to transfer that over. The second fraction is in thirds. In order to get that into 9s, I need to multiply this 3 by the factor of 3 to get me 9. So I need to also multiply the numerator times the same factor to get me my new numerator of 12. Put the division bar, which is also the fraction bar, back, and put my denominator as 8/9. I'm going to keep that there. So now I need to continue to solve my numerator in this complex fraction. Now that the denominators are the same, I can add as normal. 5/9 plus 12/9 is 17/9. Put my fraction bar back, which means to divide. We'll remember that. And then put my denominator back. I like to highlight my original fraction bar so that way I can keep my numerator and denominator separated. Lastly, the last thing we need to do in order to set up to finish the problem is to actually set it up like a division problem. So 17/9, the fraction bar means to divide, right? So 17/9 divided by 8/9. This type of problem we are used to seeing because we know how to divide fractions and we spent time dividing fractions. So when we solve it, we keep the first fraction. We change the operational symbol to the inverse of division, which is multiplication. And then we do the reciprocal of 8/9, which is the same as flipping it to 9/8. We look at the fraction and we want to look to see if we could cross reduce. If we cross reduce, it makes the numbers more manageable and easy to work with. And I noticed that 9 and 9 have a factor of 9 in common. And also 9/9 equals to 1 whole. 17 and 8 does not have any factors in common because 17 is a prime number besides the factor of 1. So now my new factors to multiply is 17 times 1, which is 17, and 1 times 8, which is 8. This is an improper fraction or fraction greater than 1. I need to convert it to a mixed number. 8 goes into 17 2 whole times, which equals 16. There's 1 left over to get 17, and the denominator is 8. So to conclude, the final answer to the original problem is 2 1/8.